Hello and welcome to this latest in the series of webcasts from Trillium Flow Technologies. My name is Chas Hawkins. I'm the Head of Sales for Aftermarket and Service in Northern Europe. The subject of today's webinar is pump re-rate and optimization. If you have any questions, please use the Q&A tab on the Zoom window. Type your question in, and at the end of the presentation, the panel will do their best to answer any questions you may have. I'm joined by three members of the Trillium engineering community today. I'll now invite them to introduce themselves to you. So if we go to Dave first, please.
Thanks, Chaz. Hi there, I'm David Smith. I've been with Trillium for about 10 years, over 10 years now, and I'm currently engineering manager for the UK services business. And we're essentially a central engineering resource that supports our service centre and customers with anything from small queries right up to larger upgrade and re-rate projects that we'll touch on some of them today.
Thank you, David. If we now move to Christian, please. Good morning, Christian.
Hello. My name is Christian Ricci. I joined Thermomeccanica Pompe in 2008, and I'm currently International Sales Manager for the Service Division. In the company, I change my roles always in project management and sales, both for aftermarket division and original equipment division. I'm international sales manager since 2016, and Thermomeccanica Pompe joined Trillium Flow Technology just recently. Thank you.
Thank you, Christian. And finally, Giovanni.
Hello, good morning. I introduce myself. I'm Giovanni Schianchi, and I am in Thermomeccanica since 1996, so more than 25 years. I covered many roles in the company during this time, starting from design department, and since 2008, I am in service department with the role of technical manager, and actually first of technical manager, and actually as a technical assistant and field service manager here in La Spezia.
Thank you, Giovanni. Trillium are a group of companies specializing in the supply and lifetime support of pumps, valves, and steam turbines. With a global footprint for manufacture and lifetime aftermarket and service support. The slide here details the significant heritage and of our well-known brands. The rich history dating back over 190 years within flow control and pumping applications. Our pump heritage of over 110 years of globally recognized brands in key industries such as oil and gas, power generation, industrial and wastewater applications. We offer both API and ISO pump solutions in all key configurations, from the more simple OH1 pump to integrated solutions on BB4 and BB5. Key to our wastewater applications are a range of VS pumps and our more specialist offerings from American plants of pitot tube rotorjet pumps, torque and screw flow non-clog pumps. We believe it's a true partnership for the life of the equipment. This allows Trillium to fully understand the operations of the equipment as well as the system the equipment's operating in. This, combined with wide service knowledge and lessons learned, allow Trillium to be a proactive service provider to the equipment operator. To add greater value, Trillium will also be happy to support for secondary products such as motors, lubrication, and other ancillary equipment to become that total solutions provider. We want to support the equipment owner from recognition of equipment requirements through full operation to end of life of that respective equipment. Recognition the equipment is required and systems will change during the life of this equipment is key to ensuring efficient operation. And Trillium achieve this through long-term service agreements, delivering key advantages such as extended operational life, optimal reliability, and maximum availability. So our focus today is around the possibilities of re-rating and optimizing pumping equipment. As you can see on the agenda, David will take us through a look on hydraulic re-rates. We'll then ask Christian to give us an overview on an energy saving piece of work that him and the team have been involved in. Giovanni will be demonstrating our Cyclops² condition monitoring system. And at the end, we'll have a quick recap and a chance for any questions and answers. As a lifecycle partner, Trillium will strive to provide the best knowledge to enable equipment to constantly perform at the best efficiency position, thus delivering the best reliability and cost savings to you, the user. And now I'll hand over to David to discuss the benefits of the Trillium pump re-rate offering. David.
Thanks, Chaz. Yeah, I'd just like to start talk through the kind of re-rates that we quite often get involved with, and we've had quite a lot of success in the past with. So first off, what is a re-rate for people who might not know really? So each pump is essentially rated for a particular duty point, and that pump would be selected and designed based on, you know, the process information and future expectations, and that would be provided by the customer at day one. So on the pump curve, we would have a particular duty point. We can actually operate to the left and right of that in a preferred operating range and wider into a more allowable operating range for maybe slightly less time. But once we start to veer away from these regions, we start to see lower efficiency, and then we introduce other problems such as recirculation, vibration, and therefore we start looking at failures such as bearing failures, seals, etc. So it becomes less and less efficient to run in these regions away from there. And Trillium, where we can get involved and start to discuss with the customer options, and quite often that option is a re-rate, in which we can essentially change the hydraulics within the pump to better suit the new requirements from the customer. So if we go into the next slide, we can see, you know, where the customers come and ask for a re-rate. Well, we come at it from different places. The first one really is a process change. So we may already know there is a big change coming ahead for more or less flow or head from the original design. Reliability, we may already be experiencing, you know, poor reliability in terms of failures because of operation away from the design point. Environmental considerations, quite a focus on targets at the moment, short and medium term with emissions. So if we can be more efficient with the pump, then that obviously reduces the emissions there. And similarly, energy costs. So quite a lot of wasted energy if we're running the pump away from the design point. So that wasted energy results in wasted money. So why would we do that, you know? Repair costs, quite often we see pumps coming in with the same problems and same parts needing being replaced. So you know, trying to reduce that by designing the hydraulics better, we try and do that. And just a consideration in terms of the original design, quite often the pump is oversized to begin with, you know, with margins added from the process teams, etc. So we're already operating off design point when the pump is first installed. So just a few things to consider. Just moving on to an example then that we've looked at recently in the new UK North Sea for one of our customers. It's a BB5 multi-stage pump, which is essentially a cartridge which sits inside a fixed barrel, as you can see there on the right. And within there, this cartridge is the area that we would be looking at. So the customer came and said, look, we have new duty requirements. Can you redesign the hydraulic bundle within this cartridge to suit the new requirements? So we were asked to look at 65% reduction in flow, which is obviously quite a considerable amount, and that was due to export rates offshore. The head was also to go down as well due to the export line pressure, which had been reduced. So we were asked to redesign the hydraulics in terms of impellers and fusers and other components to suit this, whilst having the constraints of the existing barrel, which was fixed at site, and also the fixed speed motor. So that was the challenge that was set. So how did we do that? Well, if we go into the next slide, we can see the different steps that we took. Firstly, on the right, just a high level, so you can see the original design curve with the original duty point. And then on the left-hand side in the green, that was our new target. So we had to go quite a considerable way to the left in terms of flow rate within the same space envelope. So what we did was we took it from first principle design, essentially. We've got the capability to do that, but it's not a blank sheet of paper. We do actually have the constraints in there from the existing space envelope. So we have to be a bit different in what we come up with instead of going from scratch. So we would sit and go through the hydraulic design for the impellers and diffusers, come up with the geometry and CAD model for these parts, and then we would use computational fluid dynamics, CFD, to confirm this performance. And then we actually went into an optimization phase where we started looking, in this case, more so at the diffuser, trying to optimize the diffuser design in terms of inlet angles, diffusion length, just to try and get that bit more efficiency for the customer. Once we're happy with that, what we do is we then move into the mechanical layout phase, where we take the new designed parts and lay them out with the existing CAD models of the parts that are to remain, just to make sure we don't have any issues actually that are going to occur when we build this thing. So we went through that process, and then we do a rotor dynamic study where we review the new rotating element, which is now obviously quite different from the original, to check if there are any potential natural frequency issues, and make sure the damping is okay and we won't have any vibration. So we went through that process as well. It's at that point then we decide, let's go to manufacture. So we go through the manufacture phase, through the build phase, and then into performance testing, where we have the capability of doing these tests within Trillium facilities around the world. So this one was actually tested within Trillium, and everything was satisfactory for customer. So if we move on, we can actually see about what were the kind of outcomes in terms of the design. So if you look at if we consider the actual new duty flow rate specifically, so the lower flow rate that the customer wanted, in terms of absorbed power, we've gone from almost 3 megawatts for the original design down to 1.75 megawatts. So a considerable saving there. And in terms of efficiency, we've gone up from 57 up to almost 71%. So essentially that's telling us we're running the pump in the correct position now, whereas we were operating way off in the original design. In terms of figures and benefits for the customer, well, huge energy reduction. So we have about 10.5 gigawatt hours of energy saved per year, and that equates to over $2 million using some standard energy units there. Increased availability. So because we're now operating in the correct position, we've got less chances of failures of items offshore, and we can reduce the frequency of repairs as well. And just one thing there, in terms of reduced emissions, which is something that we're seeing more from customers now wanting to look at. This equated to about, well, it was over 4,000 tonnes of CO2 per year that this actually equates to. So huge savings there as well. So a really good project. I think the customer was really pleased with it, and obviously they'll have these improvements going forward for the rest of the operation.
Yeah, thanks, David. Thanks, David. A really good example there. I think the ability to increase availability whilst decreasing operational costs. So thank you. Christian will now take us through a piece of work that he was involved with around energy saving project achieved through understanding both system and the full equipment train. Christian.
Thank you, Charles. So in this slide, we are talking about an energy saving project through an installation of pump speed control device. We will go through which are the customer challenge in this situation, which is the Trillium solution, and then we will go deeply in which are the project implementation, scope of work, and customer benefit. In terms of customer challenge, sometimes pump systems are operating in where the original design is with the fixed speeds, while in terms of plant demand and due to the seasonality of requirement, in fact, the real operating point required a different flow and different pressure from the original design. It means that pump unit is operating out of the best efficiency point region, and through a variation and closing of throttling valve. It means energy dissipation and therefore energy losses and additional cost for the customer. In such situation, a solution that Trillium can propose is the installation of a system that allow the pump working at a various speed. This can be done through an installation of variable speed coupling, this is the today example, or through the installation of variable frequency drive. In such situations, so with this solution, the pump can work modulating flow and pressure. Therefore, through this variation of speed, the energy losses will be reduced, and the pump is working always close to the best efficiency point. Okay. In general, which are the project milestone from the beginning, so from the first study up to the execution and validation of this solution. The first point, of course, is to deal with the end user in order to understand from him the current situation of the plant. So we are going to look through the documentation of pumps and motor. We are going to look to the DCS data of the client in order to understand which are the existing and the current working point of the plant versus the pump design performances. After that, usually a site survey is needed in order to analyze more data, to collect and analyze more data, and to check which are the real actual operation condition, and also the overall overview of the plant. Based on that, Trillium Flow will study a analysis all those data, elaborating this data and providing to the customer a engineering tailor-made solution, including the differences between the original configuration versus the updated configuration. In this analysis, of course, we will study which are the best practice and which is the best implementation that we can do in terms of energy savings and return of investment. Based on that, the client can decide to go ahead with the project or not. And in such case, of course, we go through the execution. It means manufacturing of all necessary components, new study of new and approach the new configuration up to the on-site installation and validation and testing. Here, just some 3D picture to make this example more clear for everybody. So this is an example of an installation of speed control device for a BB5 or BB4 pump. In the left side, you can see a picture before modification. So pumps working with electric motor at fixed speed, while in the right picture, you will see the configuration after the installation of a pump speed control device. So pumps, this speed control device and electric motor. In this configuration, the pump is working at variable speed. Okay, so which is mainly the scope of work for such kind of job. Of course, there will be a study and design of new pump skid configuration. We will provide the customer all the technical documentation from configuration A to configuration B. We will supply all the required material, including the variable speed coupling, the lubrication system, all the instrumentation, flexible coupling, base plate, and all the miscellaneous piping and so on in order to complete the supply. We will do on-site modification, required modification, providing the required manpower. We will make installation. We will verify by testing and commissioning off-site of the new configuration. This is a real picture of a job that we done in Italy, in Enel Chivasso, in a power plant. As you can see here, there is a BB4 pump installed. Again, left side with electric motor, fixed speed. Right side, new configuration. Same electric motor, variable speed coupling, and same pump with some few modifications. You see around the pump, the new lubrication system that is embedded on FOIT, that is the pump speed control device in this case. The lubrication system is integrated on FOIT and serve both pump and electric motor. In view of operation, what we have described in the first, let's say, slide is here more clear. In fact, in the left side, you have the original configuration, and in the right side, the updated configuration. As you can see in the right side, the pump is working at fixed speed, so one curve and one fixed speed. And you can see a cloud of points on the left side, which represent the real operation points. As you can see, with a pump with fixed speed, such operation point can be achieved only by regulating the valve. It means energy losses, energy friction, energy consumption. On the right side, you will see the same pump curve, but and the same real operation point, the cloud of point in black, but through a variable speed coupling, you can regulate the speeds that can be from 3000 RPM up to 1000 RPM. By modulating the speed, you are closing to the best efficiency point while you are operating the pump in a different condition. In this case, we chart the end user benefit. We have make here the end user benefit mainly in three categories. One category is the existing configuration versus the new configuration, because of course we are now talking about the modification and implementation of projects that we are doing in existing plant. So we have also to evaluate which are the impact in terms of the difference between the existing configuration and new configuration. Then the other family of advantages is how the pump, the improvement of the operation of the pump. And the third family, of course, is related to the cost. In terms of impact on existing layout, the impact are really small. In fact, the pump suction and discharge will not, the pump does not move. It means that we have not to modify suction and discharge piping. In terms of pump configuration, there are just few impact that can be done directly on site. In terms of electric motor, we don't have to modify anything since we can use the same electric motor. Again, we don't have to modify an existing electrical grid also. In terms of operation, we will see an improvement of operation because with the use of variable speed coupling, we can have benefit on damping and vibration. We can have high reliability in terms of using of variable speed coupling, and there is a really simple integration to the existing control system. In terms of cost, we will see here a really cost reduction since we have two effects. One effect is due to the fact that you are working close to efficiency point with, let's say, less energy dissipation and less energy consumption. Then you have a cost reduction to the maintenance. Since the pump is operating close to the best efficiency point, you don't have to act on the valve. It means less wear parts consumption and less main time between failure that will increment. In terms of variable speed device itself, required a major maintenance every 7 years. And in general, you have less stress on pump and mechanical components. So with this speech, let's say I just finished my presentation, and I thank you, Charles, and I give the words to, I think, Giovanni.
Thank you, Christian. A really good example there again, delivering improved operation with a cost reduction. I think now we're moving back to David, and David's just going to lead us on a short discussion around the benefits of correct selection and development of materials and coatings that can deliver benefits, technical benefits within. So, David.
Thanks, Chaz. No, that's great. Yeah, I just wanted to touch on another example of some of the upgrades that we're capable of doing and we have done in the past for our customers with different requirements. So in this particular case, we're looking at a pump that was seeing extreme sand erosion. It was a BB3 seawater injection pump, and essentially the internals of the pump were suffering severe erosion because of the significant sand content within the pump. So if we're talking about the main components, such as impellers, wear rings, etc., these were only lasting about 9 months in the existing form. And looking at the larger components, so the actual casings themselves, they were only we were having to repair them every overhaul, significant weld repairs, and the casings, you can only do that so many times. So they were typically being replaced every 3rd or 4th overhaul, and that's obviously a really large expense. So the customer was asking us, what can we do to try and improve the lifespan of these components, and therefore the lifespan of the pump in service. So if we move on, we can see, we can just have a wee look at some of the damage that we were seeing in this particular unit. So quite severe damage all the way through. In terms of the impeller, we were actually seeing the erosion right through the impeller itself, including the vanes. So obviously we don't want to be doing that from a hydraulic point of view, but from a mechanical integrity point of view, that is obviously a significant problem. In terms of the casing, we've got a couple of photos there. So looking at the split flange between the top and bottom halves, you can see that it's just starting to eat away from that split line there. And, we really don't want to be seeing that, because that will just keep going until it hits a bolt hole, which is essentially containing the pressure of the unit. So we want to avoid that. One of the more common things that we would see in this type of application is this issue at the cutwater. So, as the fluid comes out the impeller, this is the first thing that the fluid actually sees, and it just started to eat away at the leading edge of the cutwater and then just work its way back. So you've got material loss going through the pump, which is not good. And then you've also got the hydraulic issue as well. The actual design includes a cutwater at a certain position, but this obviously is changing the position of that cutwater. So you've got efficiency reduction, and also that leads to vibration and instability in there as well. So you've got further problems. And just another example of a component was the center bush there, and this was typical of most of the components we were seeing in this particular pump. So that was the issue, and then, well, what did we try and do about it? So we came at it from 2 different perspectives. The first one was a pure material upgrade side. So we're looking at seeing what materials could be used to improve the lifespan. So in terms of impellers, these were originally super duplex, and we've moved that up to Stellite 6 to improve the performance with the sand content. We then moved into using different materials for things such as the wear rings, which became solid tungsten carbide. And then we started looking at coatings as well, so coating the bushes and also the flow passages. They were actually already coated to some extent, but you know, we did go for further coating, and you know, basically anything that we could access was coated to try and minimize the issues there. So we've looked at a few things. That's like for like in terms of material change, but we also took a step back and thought, well, can we change anything from a mechanical or hydraulic point of view that actually can help with the problem of this? So in the original design, there were flow splitters. So essentially, these help the flow going into the impeller eye. And these splitters were originally mounted on the pump casing itself. But what we did was we changed that and made them integral as part of the wear ring carrier design. So that was a full insert that we could put in there in a better material. We also looked at the fitment of some of the components to the shaft. So we looked at, we introduced a new abutment ring design for the impellers. So they were solid tungsten carbide as well. So better material and a slightly different improved design as well. There was a polygon shaft, so that was in terms of changing the fitment of the impeller to the shaft. And this was to try and help with ongoing secure fitment of the impellers. From a hydraulic point of view, we also looked at a couple of things. So we spent a bit of time looking at the actual cut water profiling. So we tried to make that as best as most efficient as we could to try and minimize some of the issues we saw in the previous slide at the cut water, and also the areas between parts. So where we have mating parts, any slight misalignment of faces there and edges, then that's just where problems start. So we tried to profile the parts as much as we could in terms of smoothing that flow and reducing the erosion. So how did we actually get on in this case? Quite well, as it turns out. So I think I've just put one comparison up here just to make it straightforward. On the left-hand side, you can see the original impellers, and that was after 9 months. So this was the kind of typical kind of wear that we were seeing. And obviously that's not something any customer or pump manufacturer wants to see. So not ideal. I think if we move to the right-hand side, firstly, you can see in the centre the new wear ring carrier and splitter design. So it's slightly different. But more importantly, you can see the actual the condition of the impellers. So after this length of operation, we can still continue to operate with these impellers with the material upgrade, and obviously that's been a result of some of the other changes that were made as well. So essentially, we're looking at benefits to the customer in this case, where a lot of the components we managed to increase the life by 100% or more. And that ultimately is resulting in reduced repair costs and replacement costs. That's massively over the longer term. So huge reduction in cost for the customer there. And also increased availability. So if we don't need to be changing the pumps out all the time, they've not got that downtime where they're switching out and all the other issues that are associated with installing, withdrawing pumps, and doing rebuilds, etc. So quite a good result for the customer in this case, and I think there's some good learning for both parties in this instance.
Yeah, I totally agree. Thanks, David. Ensuring the correct materials for a changing system, delivering increased surface life, that's a lot about what Trillium's about and a lot about what we do with our technical solutions. So Giovanni now is going to take us through a short demonstration of the Trillium Cyclops 2 monitoring process system. So Giovanni, over to you.
Thank you, Charles. Good morning, good afternoon. Okay, this is a short introduction to our monitoring system developed during the years. In fact, Thermomechanical and now Trillium has developed during the years condition monitoring system for remote diagnostic on centrifugal pumps, mainly with the scope to maintain under control from the quarter most important functional parameters of the pumps, such as bearing temperatures, vibrations, but also operating parameters, the most important operating parameters, such as suction and discharge pressure, and also flow and velocity and absorbed power. In this way, companies proposing innovative service approach, starting as a first step from a real-time control of the equipment, meaning troubleshooting and corresponding corrective actions, but looking also to predictive maintenance solutions. That is, increase in the mean time between overhauling with the target to increase overall equipment life. Condition monitoring system finds application in several markets, different families of pumps, and different level of criticality. Application is now in Trillium fleet, meaning new brand pumps, but also old pumps. But we have no limitation of application also to other brands' equipments. Going to next slide, basic configuration of our system. Basic configuration is composed by wiring sensors that can be easy positioned on pump. Only requirement is one smooth plane, one threaded hole that is very easy to be applied. Sensors providing several types of measurements. Sensors are not requiring large space. Normally, the diameter is 40 millimeters, so very small. And each sensor is providing more information. To give an example, one multi-purpose sensor typically provides a signal of temperature and vibration and 3 signals of vibration along 3 axes. So a very compact solution. Data are collected locally through a Bluetooth system module and transmitted via Wi-Fi, Ethernet, or 4G GSM to cloud. Transmission device is normally located in a small junction box, normally is 30 centimeters square junction box. The junction box is positioned on the base plate, or in case of vertical axis pumps, on the stool, on the pump stool. And another peculiarity is that each junction box can be used for more units located within a distance of until 150 meters. And this is to allow Bluetooth connection. In this way, we can reduce necessary space and also the overall cost of the installation. Only necessary cable is 120 volts to feed the gateway system. We have also further option in case customer not allows installation of dedicated wireless instrumentation, proposing as a further solution by collecting data through data recorder directly connecting to the PLC, to plant PLC, that is using signals coming from available project or customer instrumentation. In this way, providing direct transmission of all available data to headquarters. In terms of storage and analysis, data are transmitted to cloud with an established sampling frequency in order to have a suitable mass of data for analysis and troubleshooting. Collected data are normally automatically processed and compared with the threshold values. These values normally are taken little lower, with lower values with respect to the normal alarm used in the plants. And in case of any abnormal value, one SMS or one email is immediately sent to engineer for analysis and start of necessary corrective actions. And this is the first important step. As a further step is to arrange predictive maintenance plans by periodically analyzing data and comparing the same with the same pump, same family of historical trends. In this way, allowing to predict and arrange when and which kind of maintenance is necessary. And this is very, very important and very innovative approach. Data and analysis can be performed through multiple devices. So here there is a flexibility of hardware, meaning a personal computer, tablet, and smartphone. Based on each contract, we can propose periodical reports or other specific reports depending by the specific needs of the customers. Regarding safety, security, that is very, very important. Data are managed with safety protocols, in this way guaranteeing high security level for the customer. Going to next slide. Regarding benefits. At the end, the benefits we can offer with this kind of service, benefit we can offer on this kind of service is to optimize in a dynamic way the maintenance activity and relevant overhauling, consequently increasing hours of operation and reducing costs. The continuous monitoring of main life parameters, in fact, allows to identify anomaly just in an initial phase. In this way, limiting possible damage and failure. But very, very important in conclusion is that the huge amount of data allows to simplify troubleshooting analysis, identifying bad actors, leading to corrective actions that could be inside the project, by applying, upgrading to design, improvement of materials, or other corrective actions on the equipment, but also, very important, how the pump is operated in terms of real operation on the plant. That is, meaning if the pump is operating far from a best efficiency point, if the pump is operating out of the curve or not in the preferred range of operation, and also how pump is maintained. That is, if we can identify bad factors in terms of poor or wrong maintenance. So this is the basic of our innovative system that during these last years we are applying on most of the population of the pump that we are producing. Thank you.
Thank you, Giovanni. Ensuring we understand how the equipment is performing is key to ensuring that we provide that full life utilization. Yes, thank you very much for that. Much appreciated. So we're proud to be a technical solutions provider at Trillium. We've been delivering this in pump solutions for the last 110 years, providing operation benefits, efficiencies, cost savings, and adapting to system changes. We achieve this through the full understanding of the design intent of both the equipment and the system it interacts with. So we recognize no pump can last forever. Whilst it's in its lifetime, we can ensure its maximum service life at its best efficiencies by fully understanding both the design of the equipment, its system, and then utilizing technically led solutions to ensure full life operation at the lowest possible cost. So we've come to the end of our main presentation. There is a short time for questions and answers. And whilst the gentlemen have been presenting and so on, we have got 2 or 3 questions and so on. And I think the first question is probably for Christian. And it's Christian, it's around the variable speed coupling solution. And could that be applied to a turbine-driven pump?
Okay, in general, steam turbine-driven pump are equipped with a governor that is designed to regulate the speed of the turbine and therefore the speed of the unit. It happens sometimes that during the years, so after operation and so on, the steam turbine can be not more available, and the client is requiring to move the driving system from steam turbine to electric motor. In this case, we can propose a solution that fit the customer, and we can make an analysis, so we can study the real operation condition, and we can make a solution that properly fit the plant needs.
Thank you for that. I think now on Giovanni around Cyclops², and could Cyclops² actually be utilized to develop a predictive maintenance schedule for a customer?
Thank you, Charles. Yes, this is one of the most important options that are available for this system. The availability of a great population of data coming from the pump allow to develop predictive maintenance programs, basically by comparing the performance, the hydraulic performance of the pump during the time with design parameters. In this way, providing a series of data relevant to a possible derating, the derating evolution of the pump during the time. And this is from a hydraulic point of view. Same is from a mechanical point of view, based on the trends coming from the life parameters of the pump, basically vibrations and temperatures. You can have an exact picture on how the pump is evolving in terms of mechanical behavior. In this way, providing and retuning the maintenance programs, and in this way providing, I say, a full optimization of maintenance on each single pump.
Yeah, thank you for that, Giovanni, much appreciated. And I think the last question, David, it's actually two questions I'm going to bring together into one, David, is around the re-rate piece, and can the Trillium re-rate process be applied to a non-Trillium pump product? And the second question within that, the links within, I think, is do Trillium performance test all units following a re-rate?
Okay, a couple of good ones. In terms of the non-Trillium pumps, the short answer is yes, and we have done that in the past. So I speak for, in terms of the UK service business, yes, but also elsewhere in the Trillium group. So the guys on the call, I think they've done that as well. So the short answer is yes. We would basically, from our side, use in the UK anyway, use our kind of APS team, our Advanced Part Solutions team, so that they have the capability of doing scanning and re-engineering and upgrades of parts and spares, and we would use their capability to actually scan the existing components, impeller and diffuser, understand the geometry, create CAD models, and create a baseline CFD and hydraulic kind of study to understand what the original pump's doing. So we would basically get all that information. We would then do similar to what we've just spoken about with the re-rate, and actually come up with the required parts. And we've recently done that on a single stage unit, actually, for a customer who only wanted to change the impeller to try and reduce the best efficiency flow rate as best they could without changing anything else. So we essentially did a new design of impeller by using all the scanning techniques with the capability of we have with the hydraulic design and CFD. So I think probably this leads on to the next question, which is testing. So in this particular instance I'm talking about, we did test that pump, but we can actually, it really depends what the customer wants, but typically, yes, we would do a performance test at one of our facilities to verify performance. But we also have the ability to do that at site if customer prefers to do that. We have field service teams, and we can also dispatch some additional engineering resource to assist with that as well, and do that at site. So it really depends what the customer is after, what the target is, and what the contractual requirements are. But yes, we can test a whole range of different pumps across the business, yeah.
So it's about flexibility. It's about being flexible for the customer's requirements as well as our own requirements as well. So thank you for that. Looking at the quick piece of work, we have come to the end of this webinar. From myself, David, Christian and Giovanni, thank you for your interest. Thank you for your attendance and your involvement. And we hope to see you soon. Goodbye.